Okay, so let's take a look at 1.4 that's on angles and their measures. We already talked a lot about segments and how we measure them. Today we'll talk about angles and how we measure them. There's a certain tool we use in geometry if we want to try to approximate or measure an angle the best we can. And we'll take a look at that. Right, so the first thing is definition of an angle. So an angle is made up of two rays. Okay, and the rays start at a common point we call the vertex. And the two rays are what make up the sides of the angle. Okay, so here's an example of an angle. So B is the vertex. Ray BC, that's the initial side. And ray BA is the terminal side. Now I've said here that an angle is formed by two rays. Well, when we talk about polygons, okay, or a triangle, any kind of shape like that, when we draw a shape, we're also going to talk about angles in a polygon. And it's a little bit different because when you have a polygon, you don't have rays. You have segments. Okay? But we still call those three things that I just numbered, they're still angles, even though they're made up of segments for sides rather than rays. Okay, but the basic concept is still the same. There's a vertex. Okay. Okay, generally, the way we figure out which side is the initial and which side is the terminal is we go in a counterclockwise direction. Okay? If you measure angles in a counterclockwise direction, that's considered positive. Okay? And if you take trig with me as a senior, we talk about measuring counterclockwise and clockwise. With geometry, we'll try to stick with positive angles. So we always measure in a counterclockwise direction. Okay? Initial side, and then where you go to, counterclockwise, that's the terminal side. Okay? And technically, there are two angles here. Okay? There's this one. And does anybody know where the other one is? Yep?
It's on the opposite side. It goes from ray BC to the other side.
Yeah, it kind of goes down. If you go in a clockwise direction and you measure this way, okay, that's the other angle. Most of the time, when I give you a picture and I'm talking about the angle, I'm talking about the one that's the shorter path. Okay? If I go down on the bottom, that's the longer path. Okay, and there's a few different ways you can name that angle. Because this angle is all by itself. Okay? One way to name it is angle B. Okay? Just using the letter that's at the vertex. Angle B. And the symbol that I put in front of B, that's the symbol for angle. It looks kind of like a less than, but it's a little bit different. This is a less than symbol. This is an angle symbol. Anyone see the difference a little bit? Okay, the bottom side, when you draw an angle symbol, should be horizontal. When you draw a less than, it's like the symbol I have on the left. Does anybody know another way we can name that angle? Okay. Does anybody know a second way you can name it? We still use the angle symbol, but we're going to involve more letters here than just the B. Yeah. Angle ABC, yes, that's correct. And the letters that he used it, you can't just pick any order. We'll talk about it in a minute, but the vertex does have to be the letter in the middle. So angle ABC is one way. What's another way you could name it, still keeping the vertex in the middle? Yeah, you could call it angle CBA. Okay, so three different ways to name the same angle. Which way we use, it kind of depends on the diagram. If we have a diagram that, say, looked like an X, and I called this, this point B, C, D, E, and F. And I wanted to talk about the angles here. There's all kinds of angles in this picture. If I wrote down this, angle B, any thoughts on that in this picture? Yep.
I can classify all 4 angles.
Yeah, we don't know what angle B is here. Is it the one on the top? Is it the one over here? Is it over here? Is it down at the bottom? So in a picture like this, you'd have to use the 3-letter naming. If you want to talk about the angle on top, it's CBD or angle DBC. If you want to talk about the one on the bottom, it's FB, that's an E. So FBE or EBF. Okay? But using a single letter won't work here. Now, if you're talking about a triangle and you want to talk about certain angles, it's fine to use a single letter here. Angle B, I know exactly what you mean. It's this angle right here. If you wanted to talk about it, you could also say angle ABC. That's fine as well. So any question on when you might have to use 3 letters versus 1 letter? You'll never use 2. It's either 3 or 1. Yep?
So if it was 180 degrees on that diagram right there,
Yep.
how would you label that? Would it be FBD?
Angle FBD is a 180-degree angle. Yep. Or you could also say angle DBF. Okay. And angle CBE is also 180 degrees. Any other questions? Okay. So let's look at this diagram and try to name all the angles in it. Okay, so I already explained this to you verbally. To name an angle, pick a point on one side of the angle, okay, then write the name of the vertex, then pick a point on the other side of the angle. So it's like you pick a point, side, vertex, side. And that's the symbol. We already discussed that. Okay, so what's one angle in that picture? Yep, Sabrina? Selena?
QRS.
Yeah, let's see, well, QRS would mean R is a vertex, if you're going to put R in the middle. So that would be like if you had something like this. This right here would be angle QRS. Okay, so we can't say QRS. We can use those 3 letters, but just not quite in that order. Do you see how we could fix that, Selena? Yes, SQR, that we can do. SQR is this angle that's in the bottom half. Okay. What else? RQS is a repeat, so don't use that one. It's just a different way to name the same angle. Yep. Kiara?
PQS.
Yep, PQS. That's the angle that's in the top half. And one more. Yep, Sarah?
PQR.
PQR, that's the big angle. And that's it. Those are the 3 angles that we're looking at in that picture. Any questions on that? Okay. So now we're going to talk about how we write the measure of an angle versus looking at the angle itself. So if you want to talk about the measure of angle ABC here, the way you write it is you put an M in front of the symbol. So this means the measure of angle ABC equals 40 degrees. Okay, normally you wouldn't want to write something like that. All right? If you're talking about the measure, you really need to put the M in front of it. When you don't put the M, you're talking about the physical object itself. You're talking about the angle. Now you're talking about something specific about the angle, its size. Okay? So the units that we use to measure an angle are called degrees. It's not the only way to measure an angle, but it is what we use in geometry. Does anybody know another way to measure an angle besides degrees? Okay, well, if you take trig, you'll learn it second day. It's called radians. Okay, most calculators have a mode on it. If you've seen RAD on your calculator, that's a second way to measure an angle. It's just like using Fahrenheit and Celsius. It's just a different way to measure it. Okay, and the symbol that you use for degrees, it's like a little circle just written up as an, almost like where you put an exponent. That's the degree symbol. Okay, degrees are often used, when you first start talking about angles in geometry, even in trig a little bit. But when you get to higher math classes, they don't use degrees anymore. There's lots of reasons why, but radians actually make things easier. Okay. But they're a little harder to learn, and they're not as familiar at first, so that takes a little time to get used to them. But eventually, they make stuff easier. Okay, and we can approximate the measure of an angle using a protractor. Okay, let's see if yeah, I've got one here. Okay, so that device that I have right there, that's a protractor. Okay, and basically the way you use it is sometimes there's a little hole right at the bottom, okay, or a little dot, and or a cross. You line that up right on the vertex of your angle. Okay, right there. So once you do that, the initial side of your angle lines up at 0. And then your terminal side, you're just looking where it crosses the protractor. Okay, so what does it look like that one is about? How many degrees? It's a little hard to see, but I'm going to make it a little bigger. Yeah.
50.
Yeah, 50, maybe just past 50. From here, I can actually see it is on about 51. But yeah, that's the measure of it, about 51. Okay, this one I think can actually help you out. It has a little thing you can drag, and if you drag it up to your terminal side, it'll tell you the measure of it. Okay, so it looks like it's just about 51 degrees. And if you press, I think it's this button, it'll actually take the angle that you have, copy it down. So if you needed to use it to draw something or make it as part of a triangle, you could use it. Okay? But that's called a protractor. It's not one of the two basic instruments in geometry, though. What are the two basic tools that I said we use in geometry? This isn't really one of the basic tools. Yep.
Compass.
Compass is one, yep. And a straight edge. Not even a ruler, just a straight object. Those are the two instruments that we can use to do constructions. This is something you can use to measure something approximately. Okay. When we do a construction, basically, like I could give you an angle, give you a straight edge and a compass, and say, I want you to cut this angle exactly in half. There's a way to cut it exactly in half. There's a certain number of steps you got to do, but it's perfect. It's not, and you're not measuring it. You're not doing any kind of measuring. You're doing a sequence of maybe 6 or 7, well, it's not that many, maybe 3 or 4 steps. And you can cut this angle exactly into 2 pieces. No measuring involved. Right, but that's a protractor. Sometimes you see a protractor, they're a full circle. This one's more of a semicircle. And I think it's more common. All right. So Just like we did with segments, we can talk about what it means for angles to be congruent. Okay, if two angles have the same measure, then they are congruent. So the way we could say that in this picture, angle ABC, angle DEF, they both measure 95 degrees. Since they both measure 95 degrees, they are congruent. So angle ABC is congruent to angle DEF. Notice I didn't put an equal sign between them. I used congruence symbol. Congruent symbol is used when you're talking about the actual object. Now, what if I wanted to talk about their measures? What kind of symbol would I use with a measure, since it's a number and not an object? Yep. I could use an equal sign. So if you're putting an equal sign, it's because you're talking about something numeric. In this case, the measure of angle ABC is equal to the measure of angle DEF. You'd never say the measures are congruent. That doesn't make sense. You say numbers are equal, not congruent. Notice here the definition of being congruent has nothing to do with where you position the angles. Okay? They don't have to be positioned right on top of each other to be congruent. Okay? They don't even have to be turned the same way. Okay? If I take a 95-degree angle and turn it, does that change the size of it? No. Okay? So as long as the measure is the same, even if it's turned, they're still congruent. Okay, so if I took this angle and like that, it's still congruent to the other one. It's just been turned. Okay, any questions on the idea of congruence versus equals? Same thing we did with pretty much a segment. Same idea. Okay, when you draw an angle, there's really kind of splits up the area around it into two different spaces, points inside the angle and points outside the angle. Okay, inside the angle, that's called the interior part. So a point is in the interior of an angle if it's between the two rays that form the angle. Okay, and you have to keep in mind, remember these rays just keep going. So it's anything that would be between these two dotted lines, no matter how far out the point is, as long as it's between the two extensions of the sides of the angle. That's the interior. Okay. If it's not in the interior, then it's in the exterior. Okay. And it can't be on the angle itself. If a point is right on the angle, it's not inside or outside, it's on the angle. Okay, so a point is in the exterior if it's not on the angle and it's not in the interior. Any questions about that classification, interior and exterior of an angle? Okay. So next you're going to look at the angle addition postulate. If you understand the idea of the segment addition postulate, this is exactly the same thing except with angles. We already had a picture earlier on that would have worked perfect for this. It was the picture where I said name all the angles in this picture. You could use that picture to do what I'm going to do right now. Or something similar. Okay, so what I've drawn is angle RST, and I've put point P somewhere in the interior. It doesn't have to be halfway between R and T. It could be anywhere in the interior. Based on what you know about the segment addition postulate, what do you think I'm going to write down for the angle addition postulate? it's obviously going to have addition in there. And if it's addition, addition involves numbers. So the only number that we can associate with an angle is its measure. So this has something to do with the measures of the three angles in this picture. Any guess or any thoughts what the angle addition postulate is going to be? Yeah?
The angle RST is
So what about the angle RST?
you combine RSP and PST.
Yeah?
So it'll be like the measure of RST is equal to RSP plus PST.
The measure of RSP plus PST. Yeah, that's basically the idea. I might write it in a little different order. But the measure of angle RSP plus the measure of angle PST, so I just said that part first, equals the measure of angle RST. And that's always true as long as you have P in the interior of the angle you're talking about. Okay, I think it's easier to see it as a diagram and then write it in words. Sometimes it's a little harder when they give you a statement like this in words and ask you to draw the diagram that represents this equation. That can be harder to do. But some hints here are, if you look at the equation, notice S is in the middle all the time. That means it must be a vertex. So when you draw your picture, you want S to be your vertex. Okay? So that's one hint. Okay? And then another hint is you're adding two angles together and it's equal to a third angle. Okay? Well, the only way that can happen is if those angles in the angle addition postulate, if they're going to share a side. Okay? Notice this angle has an S and a P in it. This angle has an S and a P in it. And that's because ray SP is shared between the two sides. So now you know what the vertex is, and you know they each have an S and a P, so they're going to share that side. And then from there, you just kind of have to, maybe trial and error and draw your picture the best you can. Okay. Any questions on that? Right, let's look at an example. So I'm going to write it out in words, but then I've got an actual picture that will help it make a little more sense. Right, so it says each eye of a horse, where the horse is wearing blinders. Anyone ever see blinders on a horse? Sometimes you see them, like if you go to different cities, like I know they do it in Rhode Island and some different cities I've been to, where they give like carriage rides, and they put these things on the horse so that he can only see straight ahead. So that way if like there's a car on the side, they don't get scared or distracted by it. They can just see straight ahead. So that's what blinders are. Okay, so it says each eye of a horse that's wearing blinders can see 100 degrees. Okay, so the left eye has a 100-degree field of vision, and so does the right eye. But there's an overlap too, okay, just like we have. There's an overlap where the left and the right eye both see 60 degrees. Okay, that's the field of vision that's overlapped between each eye. So what I want to do is try to find the angle of vision that's seen only by the left eye. Okay, so it's, if they were to, basically the horse covered the right eye, it's the part that only is seen out of the left eye. Okay, so here's a picture. There's our horse. Okay, so I know he's not Cyclops. He doesn't have an eye in the middle of his head, but just pretend. The eyes are close enough together that you basically can pretend they're like right in the middle. So 1 and 2 is basically what can be seen out of one eye. Okay? 2 and 3 is the field of vision that can be seen out of the other eye. And then 2, that's the region right in the middle that's seen by both eyes. Okay, so my goal is, if I want to basically figure out what the horse can see out of just the left eye, which is the same as just out of the right eye, it's the same answer. What am I really looking for in this picture? Mathematically, I'm trying to find the measure of what? Yeah.
Half the angle.
Well, it might not be half. The answer might not necessarily be half. But I want to find the measure of what here? Yeah.
It's either 1 and 2 or 2 and 3.
This measure I know. Okay? That's 100 degrees.
So that means you know the other one.
I do know 2 and 3. This is also 100 degrees. So what I really want to find is what? The measure of which angle? Actually, I know angle 2 as well. That's 60 degrees.
So you want to either find 1 or 3.
Right. I want to know how big 1 or 3 is. That's the angle that I want to find. 1 or 3. So I know 1 and 2. I know 2 and 3. And I know 2. Okay, so why don't you take a second, see if you can try to write down an equation first. Write the equation that would give me angle 2. And then, or I'm sorry, angle 1. And then use your equation to find that angle. Okay, see if you can do that. All right, so they want us to find the vision seen by only the left eye. Okay, so we're looking for angle 3. So how could I use the segment addition postulate to write an equation somehow involving angles 2 and 3? You don't need 1. Did I say segment addition? If I did, I meant angle addition.
2 and 3, 100% of the left eye, right?
So angle,
2 and 3 is 100% of the left eye.
okay, and what is angle 2? Yeah, yeah, that's basically it. Angle 2 and 3 is 100% or 100 degrees? Which one?
100 degrees.
Yeah, that's the 100 degrees. Okay, how do we know that? Set it right here. Okay, the angle of vision for each eye is 100 degrees. Okay? So if I want angle 3, what do I have to do on each side of this equation to get angle 3 alone? I want the formula for angle 3. Yeah, Owen?
Subtract angle 2.
Subtract angle 2. So if you take 100 degrees minus,
60 degrees.
yep, and you know what, just to be clear, I should put in the measure, because that's what we're talking about. So measure of angle 2 plus measure of angle 3 equals 100. Measure of angle 3 is 100 degrees minus the measure of angle 2. Okay, somebody just said, what is the measure of angle 2? 60. So the measure of angle 3 is 100 degrees minus 60. So what's the measure of angle 3? 40. Which is also the same as the measure of angle 1. Okay, any question on that? So now we could figure out the field of view that a horse has. How many degrees can they see, around them? Well, if we know angle, we just get 40 degrees. Okay. Angle 3 is 40, angle 1 is 40, angle 2 is 60. So what's their field of view that they can see?
140 degrees.
140 degrees. Okay? So they can't see completely what's happening on the side because their eye is a little bit in the front. But they can see 140 degrees around them. Okay? I don't know our field of view exactly.
Don't they also have a blind spot?
That I don't know either. I don't know. I know a lot of other, besides animals, like a field of view, cameras use that a lot. Like depending on the kind of lens you put on your camera, the field of view you can see. Okay? Some cameras have a special lens you can put on it so that you get a really, really wide angle. Anyone ever seen a picture like that?
Yeah.
Everything kind of almost looks, I call it like a fishbowl effect. Everything looks kind of like curved in the picture.
It's a panorama.
And it's because it's a really, really wide angle shot. Okay? So sometimes you see angles come up all kinds of different applications. Right, so we classify angles based on their measure. Okay. One type of angle is an acute angle. Anybody know the definition of an acute angle? Yeah, Luke?
Angle less than 90 degrees.
Yep, that's good. Less than 90. And there's one more part to it.
It's not more than.
Well, the less than 90 covers that, yeah. So it has to be less than 90, but it does have to be more than something else. Yeah. Yeah, it has to be more than 0. If the angle is 0, then you don't really have an angle. And then if you have a negative angle, like negative 10, that's not an acute angle. So there's a picture of an acute angle. Less than 90, more than 0. Okay, a right angle. Okay, right angles, they come up quite a bit in trigonometry when we use triangles. Okay, so right angles are important. Selena? It has to be 90, yeah. It's exactly equal to 90. And when we draw an angle that's a 90-degree angle, or a right angle, we put this little symbol on it. It looks like a little square in the corner of the angle. That means that the angle is 90.
It's negative angle of like.
A negative angle? It just goes in the other direction. Goes that way. Goes clockwise. So the initial side is still horizontal, but the terminal side is, it's like you're going clockwise to get to the terminal side. And that is the shorter path. Okay, so that's a negative angle. Okay, what's the next kind of angle we have? A little bigger than a right angle. Next category, yep. Yep, we have obtuse angles. And what's the definition of an obtuse angle? Connor?
More than 90, less than 180.
Yes, has to be more than 90, but it has to be less than 180. And one more type, well, it's a couple more types. I think we're only going to do one more, though, for what we study. What's another type of angle? So we have acute, right, obtuse, and Denver?
Straight angle.
A straight angle. What is that? 180 degrees. Okay, so a straight angle is basically an angle that's formed by two opposite rays. And the measure is exactly 180. Okay, so next example, I've drawn a picture. And I'm going to put down some different angles. There's a bunch of angles in that picture. And I want you to classify the angles as one of the 4 types I just gave you. Okay, so start with angle CDE. CDE. Okay, what kind of angle is that, Nick?
Right angle.
That's a right angle. Okay, next one is angle BDE. BDE. Selena? Yeah, that's obtuse. We don't know how big BDC is, but we know CDE is 90, and then we're adding more to it, so it's got to be obtuse, but it's not quite enough to be 180, so it's not that type. Okay, so this one's obtuse. How about ADE? ADE. Yeah, Alyssa? That's a straight angle. straight angle, measures 180 degrees. And how about BDC? What does that one look like? Kira? That's acute. Sometimes if you have an angle that measures more than 180, that we do use a term for it. It's called a reflex angle. If you look that up, a reflex angle, they usually classify as an angle more than 180 degrees. Hey, any questions on that? Okay, so there's a lot of terms that we learn with angles. There's some terms I don't even think we're going to get to today, like complementary and supplementary. We'll get to those eventually. Okay, but the next one is adjacent. Okay, two angles are adjacent if they meet all those criteria. They share a common vertex. They share a common side. But they have no common interior points. There's an example of two angles that are adjacent. A is the common vertex. The side they share is AC. And there's no way that if I put a point inside the blue angle, it could also be inside the red angle. That's not possible. Likewise, if I put a point in the interior of the red angle, it could never be inside the blue angle. Right? So you have to meet all those criteria to have adjacent angles. Would those be adjacent angles? What do you think? Talking about this one and that one. No. What do they share?
They share the same vertex.
They do share a vertex, but they don't share a common side. Okay. Let me show you another example. There's one. There's two. Now those angles do have a common vertex. They actually have two common sides. But the problem is if I put a point inside the green one, it's also inside which other one? It's inside the black one. So these angles are not adjacent. Okay? Question? Yep.
So if you go from DAB and you do what's called another angle, like you could do a reflex angle.
Outside, like here?
Yeah.
Yeah, if you were measuring that, that would be considered a reflex angle.
But would that also be adjacent?
Well, you could draw, if you drew something like this in, now the red angle and the green angle are adjacent. That's a third one, yeah. Okay. So for tonight, okay, for the homework on angles, it's on page 29. It's 2 to 22 even, 26, 36, 46, and 48.